180-degree opposite to my plus x. So it's minus. Has to be minus. Do you get it? Any question? Are you convinced now? What about the second one? The inner. Negative 1. Let me stop. I want to make sure you understand why the sign is the way it is. Because if you don't, we have to stop.
So never change the order of your terms, just change the signs that you use.
The order of the term is always out being positive minus in always. Always. Okay? Out plus in negative. Okay? Yes?
So if there was a pressure increase from 1 to 2 instead of a pressure drop,
Okay?
would the term be negative, like negative P2 GA2? How would that?
The answer is yes. If the pressure is higher at 2, which is not physical. Why? Because if I want to push the flow go from 1 to 2, pressure and the water has to go from the higher pressure to the lower pressure. Right? But aside from that, if the pressure is higher on this side, then the pressure will change. Right? Which is some problem you have to deal with in your homework. When you don't have a feature, when you have flow inside a pipe that's not open to empty. Yeah?
And so then if the pressure drop, like it is here, if the pressure drop is great enough, then the force will be in the same direction as the flow?
It all depends on how the number works out.
Okay.
There are 3 components of forces. I don't know a priori
Okay.
which one is bigger.
But that is possible?
That is possible, but unlikely. Because pressure in most problems has to go from high to low. Right? Think about the physics. It's almost like water can only go from high elevation to low elevation. It's free flowing. But the sign is what it is. You just have to religiously follow the sign, including the velocity like shown here. Yes?
So if you have a diffuser, could your force technically be in the opposite direction because you're...
You don't know yet. The question is, if you change the problem to something like this, the flow actually decelerated. I don't know, and I have to work it out. You have to tell me the pressure, tell me other conditions. I can't just say, I can't give the answer a priority. Right? You have to account for all the forces and all the change in momentum. Any other question on this second piece? So if I simplify the algebra, and take out the sign carefully, what can you conclude? Okay, you can compare A versus B. Same. Same. Physically, the force to hold the nozzle is still pointing to the left-hand side, despite your choice of the coordinate. Right? This is called the law of common sense. Do you understand what I'm saying? So you have the fluid going through this nozzle. Do you care how John Smith choose to look at the x coordinate being plus or minus to the left or right hand side? No, I couldn't care less. Right? The physics dictate this has to be independent of the coordinate. So one last detail is the force. So for many problems moving forward, you have no idea the direction of the force. So I'm going to do one more example to convince you that it's not important what you assume. Same control arm. Same PA. Now I go back to my plus X, pointing to the right. With one exception now, I'm going to say the problem is such I don't have an intuition as to which way the anchoring force should act. I'm going to call it applying. I'm just going to assume or pretend it's going to actually point to the right. And I'm going to rewrite the problem. That's all I change. All the quantity, velocity, pressure, all the same. I happen to choose the same coordinate as case A, this is case C. Now let's just rework this very quickly. So fill in the sign for me, including F prime. Start with F prime, what sign? Positive. Why? Because it's parallel to my plus 6 direction, so it's positive. Pressure? Positive. Right hand side? U2 positive, U1 positive. All right, are we square on this? Okay, so now, again, just simple algebra. And sure enough, I have the same magnitude of the force F. Because again, common sense tells me the flow doesn't care which you assume the anchoring force to be. The minus sign. What does that mean? What you assume here, positive to the right, is exactly opposite. The final force will be pointing to the left, which is what we have on the left side, case A. So it's a little tedious and time consuming to go through that, but we've done it once and for all. So do you understand what has been done? Yes?
So you have the pressure times area is positive. If there was a pressure on the other side, is that negative?
If you have a pressure on the other side, which you will deal with in the homework, okay, it will be not a free jet, it's actually a pipe. And the pressure acting on this side, maybe I should reserve that for the homework. I can answer that now. So if there's a pressure that is not atmospheric on the right side, how do you account for that? Which way the pressure will act, first and foremost? Inward and normal, independent of the flow velocity, I don't care. Once again, it's not submerging this control volume underwater. Right? All the pressure force through the hydrostatic will be always normal and inward. So the pressure force here will be, and whatever you tell me it is, I have to account for that in the direction shown towards the control volume. Right? And we'll do that for the homework. That's exactly the new twist. Yes?
In the Combustion test, if we got an answer to that problem of like -10, do you want us to clarify that it's like 10 in the going left?
You have to, yes, very good. Unless your coordinate system is clearly labeled, so we can trace that. To be safe, spelling it out will be probably the best option in case